All right, let's start today's lectures. And today we're going to go over lecture 4, two more example, and you can download the simul model here and go with it. And also I already have a video uploaded here. But anyway, we're going to starting the entire process from scratch. Let's do the PowerPoint first and see how that goes. So this is today's two more example, and really simple example, similar to the last one, but we go a little bit faster. See if you can follow up our path. So pace. Oh, I'm sorry. So here is the so-called Care Harris restaurant, and this restaurant only open for dinner and open from 5 to 9 o'clock. And customer arrived to the system, to the restaurant by parties, and there's 40% of chance 2-person party arrives, and 30%, and there's a party of 3, 20% party of 4, and 10% party of 5. The inter-arrival time is exponentially distributed with 1.6 minutes on the average. All right, and customer arrive after 9 o'clock will be rejected. So like a regular restaurant, 9 o'clock, the door will be closed, but however, the restaurant stay open until all customer leaves. Okay, until all the customer leaves. And the restaurant has a 50 table, and each table can seat 2 person. And the restaurant has a limited space for waiting party. So if the restaurant is full and people can wait in the waiting line, however, the waiting line capacity only accommodate 5 party. Beyond 5 party, the customer will be rejected and will leave the system. Okay. And once customer got seated in the restaurant and they order their food, and cooking time takes about between 15 to 20 minutes, and most likely 18 minutes cooking time. And after that, the party will dine, follow a normal distribution with 20%, okay, 20% of a chance. And after they finish dining, and there's they go to the cashier service and to pay their bill and leave. So we want to know number of customers served, okay, number of customers served, and number of busy table, how many table are busy, and number of waiting customer in line, and number of party that leave without eating. Finally, we want to know the utilization of the party. Okay, so these are the description for the problem. So we're going to start looking at the model first. Model looks like that, and we're going to start building a model. So we'll have a source, generate customer arrival, and then they go into a dining room, and after the dining room they go to the cashier service, then they leave. So it's really simple, and there's a trick. We need to determine how the customer got rejected in that case. Okay, so here what we have, we start with a new simul model, blank, and then we can start from there. show you how to build this model. Move this to another window so we can all right. You're ready also? Open up the CMail with me and start with this. We're going to do this relatively quick. We have one source, one sink, which is coming and leaving, and then we have two servers. One is dining room, one is cashier. So the first we're going to call this guy, just so you get used to our party arrivals, okay, source, and sink is the exit. All right. And the first server right here is the dining room. Okay. Second server is the cashier. So far, okay? Okay. If this is okay, and we're going to link them together using path. All right. Looks like this is a little bit messy since all the paths are a little bit the left-hand side, the gray node usually represent input node, and the blue diamond here represent the output. So I'm trying to do is line them up a little bit. So I can do is I'm going to move this over here and move this over here. Just reverse the input and output node. Okay, you can see that, what we do. And also remove the output exit from here to here. And I can make them smoother so that it looks like light up. Okay, this is what I have. A little bit here, so they kind of line up. Everybody okay with me so far? Okay, so inter-arrival time for the parts should be, say, 1.6 minutes per arrival, correct? 1.6 minutes per arrival. Oops, sorry, not this. I'm going to reset that to 1, and this is the part. So again, it's random exponential of 1.6 minutes. Everybody kind of follow what I'm doing? Okay. If you do, and that's all there's to it. Okay. Over here, the dining room, supposedly I have a 50 table, but look at the capacity I have right here. The capacity, I only have 1. There's a way what I'm going to do is 50 right here, meaning I have initial capacity of 50. But remember the presentation we have. So we have 50 table. each table seats only 2 people, okay? And the party arrival could be 2, 3, 4, or 5. So that means if the party only 2, they're going to occupy 1 table. If party of 3, they're going to occupy 2 tables. A party of 4, they're going to occupy 2 tables as well. If a party of 5, they're going to occupy almost 3 tables altogether. So determining the party size, I need to determine how many tables they're supposed to be seized. So this is what I have in mind right now. So what I'm going to do, instead of setting this capacity of the server, the dining room, for 50, I'm going to set it to infinity. Okay. So that means there's no resources required inside the dining room. However, I'm going to grab a resource on the left-hand side. You see this symbol, resource, and put it over here. And we call that resource table. So here we start learning using another object called resources to represent number of a table we have. So over here I have capacity of 50 table. Everybody okay? So if this is okay, so this is what we do for now. We have 50 tables, but when the parties arrive right here, I need to determine how many tables I need to grab. First, we're going to, before I forgot, we're adding a default entity. We call this party. Okay, party entity coming in, generated by this resource based on 1.6 minutes. However, over here in this dining room, instead of grabbing resource within the server itself, I'm going to using a so-called secondary resources right here. Okay, the secondary resources, and so we're going to use in here. Okay, so here I'm going to grab the resource first. Is going to using resources for processing. I'm going to go in here to add the resources I'm going to grab, which is now tables. Everybody see this? So for in the dining room process, I will try to get a secondary resources for processing. I can add a couple more resources right here as well. So this is like a repeater group. You can see multiple resources for that. And the only thing is troubling is how many table we need to process. Like we said, if there's a party of 2, I need 1 table. If party of 3, I need 2 tables. If it's a party of 4, I need 2 tables. If a party of 5, I need 3 tables. So, and each table only can accommodate 2 persons. So what I most intuitive portion is the party size divided by 2, but I need to somehow set it up. All right, so let's take a look. Now, inside the source right here, I need to have a so-called model entity state variable represent party size. Okay, so each party arrives and has a default party size, and we need to assign them. So in the model, so once I decide this party size, define this party size, I need to kind of assign it over here. So before, in the source objects, before they leave the source, I need to kind of assign them a so-called model entity party size. Okay, and this model party size should be a number of 2, 3, 4, or 5 based on the probability we have defined. Let's do that one more time. Okay, sorry, 40% person of 2, 30% party of 3, 20% party of 4, 10% party of 5. So how are we going to do that? We're going to do same thing. Let's expand this. Click on this pull down menu here, right here. So random and discrete. Okay. We've done this before in the last lecture. What do we do? Party of 2, how many percent? 0.4, okay, 40%. Party of 3, another 30%. So accumulated to 0.7. Party of 4, how many percent? Another 20%. So this add up to 90%. And party of 5 add up to 1.0. Everybody follow this? Okay. Using a random discrete to determine the party size. We've done this in the last example, so we repeat this again, just reinforce you learned this. So after we have a party size coming through, over the dining portion, when we seize the table, by default is 1. You guys see this? But I want to do, let's see if I can, save some typing, model entity, dot party size, divided by 2. So if I just using this, okay, divided by 2, then party of 2 will end up with 1. Party of 3 will end up with what? 1.5. But I need 2. Party of 4 divided by 2, I end up with a 2. Party of 5 divided by 2 is 2.5. So I need to actually end up with a something in run up or run down to what I have. So easier things we have is what I do. Party plus 1. Let me go really heavy. Okay. So model entity party size plus 1 divided by 2. So if it's 2, I have plus 1 equals to 3 divided by 2. Then I have 1.5. In that case, I'm running down to the largest integer less than this number. So what I can do is I'm going to call the math function called flow. So running down to the closest integer. Everybody follow this? Fairly simple, straightforward. So that will give me the proper table quantity to seize. Everybody okay? I'm going to stay here for a little bit. All I can do is what? Party size. Oh, I'm sorry. Model entity. Party size divided by 2. But I wanted to have math dot ceiling. Same thing. Okay? So either way, we can follow this. If you have any question, please let me know. Otherwise, I'm going to move on. Okay? Sure. Yep. I can do it here, larger. Sorry. I'm going to start with the party size. This is better, easier to see. Okay. You can type it in the small font. I'm using PowerPoint. It's probably easier for you to see. So what I have is model entity dot party size is the attribute I just defined, equals to random discrete of following. Party size of 2 something, 3 something, and 4 something, and 5, correct? Something. So the second parameters of this discrete distribution represent the cumulative probability. So how many percentage of party over 2? Can you help me out? I want you to follow me. 40%, correct? Am I right? All right. And then for party of 3, I have additional 30% add up to it. So that will be what? 70%. Okay? So party of 4, I have additional 20%. So add up to 90%. Up to party of 5, add up to the rest of the 10%, I have what? 100%. Can you do this yourself in the assignment block right here? Before they leave the source, this is a small print, so you may not see it clearly. Is this okay? All right, similar situation right here. Determine how many table would, yes. Go back to the model entity, go to definition, and the state variable. We've done this last example, similar using what? Job type, status, remember? Priority. Yeah, we done this before, so this is just another exercise. Okay, so you see that we go to definition and state variable definition, add an integer state variable called party size. Make sense? I'm going to redo this one more time on the PowerPoint. Determine how many tables I want. Go back to the PowerPoint. So here the second thing is tables needed, correct? Make sense? Okay. So table needed is 2-person party. I need how many table? 1 table, correct? And 3-person party, I need how many table? 2 table. And 4-person party, I need 2 table, correct? And also 5-person party, I need 3 tables. All right. So what do we do here is we're using model entity, party size, divided by 2. That will give me what type of value? Party size equal to 2 divided by 2 will give me 1 table, correct? Party size divided by 2, I will give 1.5 table. Party size for 4, I'm going to get 2 tables. And party size divided by 2, I will get 2.5 table. So actually I want is 1.5 go up to 2, 2.5 go up to 3. So what I have implemented here, I'm going to do this model entity party size plus 1. Okay. In that case, I will get 1.5 here, 2 here, 2.5 here, and 3 over here. Make sense? The calculation. And then I'm using a math function to round it down to the closest integer, and I call it floor. So that will give me the proper number of table I need to seize. To seize the table, one more time, and the secondary resource required for processing, I'm adding one of those over here called table, choosing table, and I put that function over here, calculation over here for processing. Okay? If not problem, please interrupt me or get my attention since I'm dealing with, cameras and PowerPoint and CML models and meetings. I may not pay attention exactly to what are you calling for, but I try my best. Please raise your voice and either turn on your camera or tell me what's your name so I can communicate with you properly. So here we have one more thing I need to resolve. It's the processing time for this dining area. So what is the processing time? Let's go back to see. A cooking time takes a triangular distribution between 15 to 20 minutes, most likely 18 minutes. And the dining time for the party altogether will be 20 minutes with a standard deviation of 2 minutes. So how do we actually implement this? So here we have in the processing time, I have by default is a triangular distribution. So triangular distribution is exactly what I use first. So that's the cooking time I'm going to dealing with first. So 18 and 20. So that's the cooking time, correct? Then plus the dining time. So it is a random distribution again, but it's a normal distribution with a mean of 20 minutes and standard deviation of the 2 minutes. Make sense? So the processing time, which is the time the party stay in the dining room, is about the cooking time plus the dining time. Did I make sense? After the party finished dining, it goes to the cashier area and to pay. And the processing time follow normal distribution with the 2 minutes with the standard deviation of 30 seconds. So same thing, I'm going to easily change the processing time, call random, normal, with a mean of 2 minutes with the standard deviation of 0.5 minutes. Did I make sense so far? If no problem here, so the customer, after they're done, they go straight to the exit portion. The problem's done. All right. Next, what I need to do is determine the party actually, if the party's entities over here equals to more than 5 party waiting in the line. So I'm going to start running this, see if it works. Okay, you see parties start coming. Let's make it bigger, quicker. It's hard to see how many parties are in here. Actually, I can do that. I can see how many down here. And also, I want to see how many tables currently are occupied or remain. So what I do is click on the table. Please follow what I'm doing. And this is kind of important for the rest of your semester as a debugging process. Highlight this table resource and choose the status labels right here. And putting a number right here. Everybody can do this. Highlight the table first. Choose the status label. Okay. And click on the status label attached to the table. Everybody see this? All right. So you see that this particular label is attached to that table resource. What I'm going to do is capacity. Okay. Capacity. Allocated. So now you see that how many tables are occupied already on that. So we get the pretty much an idea how busy the table is, the dining room is. So now we have 34, 35 tables actually occupied. And then some of the customer leave. Everybody okay? And question for me? All right. Let's see. All right. Question for me. That pretty much the model is built. We have a couple final items to establish. One is we need to reject this process. Okay, reject this process if it's 5 or more party waiting in this waiting line. But so far we haven't reached the 50 tables yet, so we don't have anybody in here. Okay. So we can also add it something like that, similar situation, and add this. I'm going to have a status label also here for the dining room. I'm going to do input buffer dot capacity content number of waiting in that input buffer. Okay, So input buffer contains number of waiting in the dining room. Input buffer is this green line over here, and how many entity waiting inside this portion. So I'm going to leave a little bit room for you to exercise. Instead of trying to see how many, instead of a 50 table, maybe we have a 30 table right here, and see how that goes. To create some effect, we have entity waiting in the queue. So now you see there are entity parties, actually parties waiting in a queue. Everybody see this? And the queue gets pretty large, and sometimes 5 is 6 and 7. But we want to eliminate or limit the queue's waiting size equals to 5. If it's more than 5, I'm going to reject that party. Okay. Take a look how we're going to do that. Over here in the server dining room, okay, I'm going to create a so-called transfer in constraint. It's in the advanced section options of this. I'm going to stop the simulation for now. Okay. Goes to the advanced options over here, and there is a so-called transfer in constraint. Everybody see this? Underneath here, transfer in constraint. Instead of using default transfer in constraint, I'm going to define a customer condition. Okay, customer condition. I'm going to see something putting a constraint over here. What kind of constraint I need to put? Actually, it determines on the number of parties waiting in front of the dining room. So I'm going to copy this value over, come in over here again to say, oh, all right. So I'm going to paste this over here, input buffer, okay, input buffer contains number of waiting is what? Less than 5. Okay, here we're going to do also, try to make sure dining room dot. Just say dining room input buffer contain a number of waiting, okay, and less than 5. I let them come in. Otherwise, I'm going to reject it. Everybody okay so far? So in the dining room object, there are input buffer objects within the dining room. The input buffer's content, what kind of content? Is number of waiting content in that input buffer. Is less than 5, I'm going to let it in. Otherwise, I'm going to reject it. To let you see the whole equation. Now I'm going to have a second sink over here, and we're going to call it reject. Similar situation, I'm going to move this input buffer, input node to the right so I can have a little bit better connection layout. Okay. Question? Looks like everybody follow up pretty good. This is a simple example. And also similar to this situation, I want to see how many parties are get rejected. Okay, so click on the sink one more time, highlight it. See this red dot around it means you highlight it. Choose the label. I want to see how many got rejected, basically how many parties actually coming through this input buffer of the sink. So over here, I'm going to start typing one more time. As for the reject objects, I'm going to call input buffer dot what? Here, I'm going to call number exit. How many exit in input buffer? And I'm going to play around with the background over here. So highlight, you can see each one of the label we have so far. I can do something like that and change this to white. All right, let's run this, see how it works. Okay, input buffer start getting accumulated. Once it reaches about 5, it start getting rejected. Everybody see this? Okay. Question? If not, we're going to move on to the next issue we need to resolve, basically. Go back to our presentation, actually. One of the things is the restaurant, we're going to reject all the customer arrival after 9 o'clock, but the restaurant would remain open until all the customers leave the system. How do we do that? First, I need to stop the incoming arrival at the 9 p.m. And also, the restaurants start with 5 p.m. all the way to 9 p.m. Let's take a look. First, we need to fix the starting time and the ending time for the restaurant. First, I'm going to start with 9 p.m. Okay, that's the starting time. And the ending time should supposed to be 9 p.m. And for the same day. So on the same day, start with the 5 p.m. Start with the 5 p.m., run to the 9 p.m. So let's run this. Stop the simulation right at the 9 p.m., but I want you to pay attention at the 9 p.m. what happened. We still have plenty of customer inside our system, correct? We still have plenty of customer haven't finished. But I need the simulations to run continue until the last customer leave. But also at this point, 9 p.m., I need to shut down the source. So let's shut down the source first. Okay, let's shut down the source first. By here, you see a stopping condition, okay, in the source. Maximum arrival, you can stop the source after they generate certain number of arrival, or you can stop the source after certain time. Here is exactly what I need. So I need to stop generating future arrival after 4 hours, between 5 to 9. After 9, I'm going to shut down this source. No more party will be incoming. All right, let's run this again, see if it works. Still, even after 9 p.m., at the 9 p.m., I still have plenty of a part. So I was effectively shut down the source. However, I shouldn't stop the simulation. I should let it run continuously, see if what happened. So here I'm trying to say is, I'm going to let the simulation runs, end of the simulation run is undefined, which means infinity. Once the last entity leave the system will automatically shut down. Okay, so now you see at the 9:45, almost 9:55 p.m., and all the entity leave the system. Everybody see what I'm doing? And the system is empty. Automatically, the simulation will be done. And I can go back to the result and seeing, how many party got generated. 140 party was generated by the source. Okay. And look at the sync. I can determine how many party finished dining. 113 party actually finished their dining, and 27 party got rejected. Everybody okay with me? At the 9:55 p.m. that night, and the simulation stopped, all the customer leave the system. Any question for this example? This is a very simple example. 2 server, 1 source, 2 sync, 1 for the reject, the other one for the exit. And the most new things we learn is, we learn first how to stop the source, either based on the count of arrival or based on the time limit. Okay. Second, we define a model entity state variable called party size. Based on this party size, I seize the various amount of resources defined. This we call a secondary resource. We'll call that table. So the original dining room has no capacity, which means I don't need to define any capacity for the server. And the maximum amount of a party stay in this server is limited by the secondary resource. And the secondary resource is seized by number of people in the party. Okay. Also, in this example, what we do is using advanced option in the server, define a customized customer condition if the input buffer contents number of waiting in the screen line is 5 or more than 5 already, and then we will reject our incoming to the server. And then we're going to reroute it into the exit, so I can count how many people got rejected. Question for me so far? Okay, we're going real quick. Took almost an hour. If not, we're going to go to the next example. The next example we have is an emergency room example. You can download the model already from the canvas. You can follow what I'm doing on the video. The emergency room example, patient arrived to the emergency room based on exponential distribution as 0.3 hours, which about, 20 minutes or so, or 18 minutes or so. Okay, and patient coming to the emergency room have a category. The category is either number 1 is open wound, which is most severe condition. It's 6% of a patient going that way. And second is close injury, because internal injury type of things, bruises, concussion, those type of injury is 8%. Multiple trauma, okay, and fourth is a visceral complaint, which usually means stomach pain, headache, shortness of breath, and so on. And number 5 is so-called chronic complaint. I have a backache, I have constipation, so on and so forth. Those type of situations, not as severe, but you need to see a doctor right away. And category 1 patients are most severe, send it to bed directly. And other ones need to fill out the registration and go through the so-called triage. We call the so the nurses collect your medical record, then send it to bed. The emergency room has 3 beds, okay, 1 registration nurse and 2 doctors on staff, okay. So we want to simulate the system for 30-day period, record the statistic, utilization of the resources for the bed, for the doctor, and for the nurses. And also, very important statistic is the time the patient spent in the system. Okay, time. We're probably not going to be able to finish this example, but I have the full video online already. The treatment time inside the ER is follow triangular distribution with mean, mode, and max, which is between minimum possible time, maximum possible time, and most likely time. So for 5 different categories. Okay, so we're going to start this example. Any questions so far? Is this too fast, too slow, or about okay for your pace? All right. So now we need one resource again for the patient arrival. Scale down, 1 sink for the patient leaving the system. Okay. And then I have a 2 server again, 2 server. One we call this registration. Okay. The other server we call it bed. All right. So I'm going to connect them with the path, double click so I can continue to use the tool. So server go to the registration, and after the bed they leave the system. And also for the category 1, I go straight to the bed. Okay, done. And also how many bed I have? I have 3 bed. Okay, 3 bed. So capacity of this server equals to 3 bed. And I have 1 registered nurse. I'm going to assume it is within here. Inter-arrival time, exponential distribution of 0.3 hours. 0.3 hours. Make sure the unit is correct. 0.3 hours. Question for me. All right. If not, we also have a doctor, physician on staff. We call it doctor, two doctor. We have two of those. We have two of those doctor, three of the room, three of the bed, one of the registration nurse within that registration station. And that's all there's to it. And needed patient. The patient's entity coming in. And as we said it before, we need 5 category. So I'm going to have 5 symbol. Okay. The first level is most severe. I'm going to using red. Everybody see that? So second category, I'm going to using less red. And third category, I'm going to use yellow. Fourth category, I'm going to using blue. And the last category, I'm going to stay on green. Everybody okay with me? All right. So if this is okay, so I'm going to, based on the arrival, I'm going to do a stay assignment one more time to determine what type of patient they are. Again, I need to have a patient category. So go back to the model entity one more time. Definition, stay variable, integer. I'm going to change this integer to category. Okay, category. Go back to the model here in the source. I'm going to do the state assignment to what? Assign their category. So here what we have is model entity, category. Equals to, what is it? Go back to the PowerPoint. 6% category 1, 8% category 2, 18% category 3, and 32% category 4, and 35%, another 35% category 5. I'm going to do this. So, model entity, dot category, equals to what? Random, discrete, category 1, 2, 3, 4, 5. Similar to what we have. Category 1, 8%. How's that? Category 2, another 18%. Add up to 32%. Category 3, how many percent? Let me see. Oh, sorry, 8% and 18%. Let's do that. 8%, that's 6% first, and 8% second, that will be 16. Another 18%, that will give me 0.34. Make sense? And another 32%. Will give me 6%. All right. And finally, 35% will give me 1.0. Question for me. Everybody okay? So I'm going to copy this over to the assignment block I have. Oop, maybe I have. Sorry, don't need this. So you see, if I make the arrow, it's automatically prompt me where the arrow is, okay? And then I can come back to modify it. Once I assign the category, I need to determine the processing time in the bed. So what I have to do is go to the data section, create a table, and I'm going to create an expression table. Called up treatment time. And treatment time is, the unit is time, is based on minute. This is very important to determine the unit type. So here, and the processing over, I can see the treatment time is a triangular distribution based on the mean, mode, and max for each one. I'm sorry, these are all hours. Huh? All right, let's do this with it hours. To save time, I'm just going to make a copy. First, I'm going to just duplicate this. Okay, 5, and then I'm going to come over here to copy them. And change the parameter. Okay, change this to hours instead of a minute, and that's my processing time. Everybody okay? All right. If that's the case, also, I need to determine which type of processing time for which type of row it is. So here I'm going to show you a little bit. Before here, I have only assigned it what? The party side, the category, patient category. I may as well change the picture. So model entity, picture. Equals to model, and let's do this. We've done this before. Model entity dot what? Category minus 1. All right, so that's give me the picture. Question for me. All right, so now inside this best server, I'm going to set which row on this table it is. I can using an index like a previous example, but today I'm going to show you a little bit different way to do this, okay, using a command called set row. So on this particular table, I want to set 1, 2, 3, 4, 5 based on the patient category. How do I do that? So inside the server, what I do is I'm going to do an add-on. Okay, process trigger, add-on process trigger. And let's do it. Why don't we do a different? Upon arrival, okay, we do an add-on process trigger. So when the parts got just generated, the patient got just generated, after we create, so expand this add-on process trigger, once the entity is created, okay, I can create a process. First is we're going to double click on this. Okay, double click on this. So it automatically create an empty subroutine. Every entity got just created, it will run this small subroutine. The subroutine, I have two things. First, I'm going to assign the category. Oops, sorry. Equals to what I just have. Okay. Second, I'm going to assign picture. And the picture equals to model entity, category, -1. So here is an alternative way I can replace these two assignment issues in a subroutine. So here I'm going to delete these two since I already have it running somewhere else. After the entity was created, I already have this. Okay, so first one is assign category. Second is assign picture. And the third, I'm going to using a set row. All step, go all the way down to set row. We're going to come back to this. I'm going to set row, which row it is. Choosing that table 1 is my table, which is the processing time. And row number is model entity category. Sorry. So based on the patient's category, I'm going to set which row of this table 1 I'm referring to here. Make sense? Okay. So based on table 1, patient category is category 1. I'm setting to the first row. If category 2, I'm going to set it to second rows and so on and so forth. And then once I do the set row, over here the processing time is easy. All I have to do is table 1. Should be processing time. Whoops, sorry. Did I have a processing time defined? Data table treatment time. I'm sorry. It should be over, not this one. Should be in the room. So this one should be table 1. Dot treatment time. Since I already set rows, we'll know under treatment time which row of corresponding table it is. All right, so we can run this. So this is a fairly simple process. We almost done. We got 4 more minutes. We need to include doctors in here. Okay, Like using the restaurant example, instead of I have tables, here I have a doctor. So I'm going to, using secondary resource, I'm going to include a doctor's over here, resource, as part of the process. So I'm using doctor as a secondary resource and within this server situation. Okay. Question for me? We'll pretty much finish this example. We're going to come back to for some enhancement next lecture period. Otherwise, we're done for today. Any question for me?